Hello everyone, my name is Sarandas. Today we are here to present about Engineering Mathematics Chapter 5 Vector and Scala. Introduction. Scala is quantities that have only a magnitude. Example, mass of an object and speed of a car. Vectors as quantities that have magnitude and direction. Example, velocity of 20 meter per second due to south is not the same as velocity of 20 meter per second due west. Example of scalar quantities, speed, potential work, energy. Example of vector quantities is velocity, electric and magnetic forces. Position of a robot arm. In books, scalars are normally printed in italic font, while vectors are usually in regular font but bold. In writing by hand, it is a conventional to give vector a wavy underline or an underscore. In these notes, the vectors will be emblazoned. It should be noted that in some application, vector must be tied to a particular reference point. Example, in describing position of a robot arm. In some other application, we have free vector which can be moved around. Delay, we must not change their length or direction, but otherwise the absolute position is irrelevant. Okay, the next is basic concepts. Since vector have direction as well as magnitude, a graphical representation is very useful. Consider the line segment AB of length 3. This can be represented a vector in the direction shown by the arrow on AB. This vector is denoted by AB. Note that BA may be not equal since the vector AB is directed from A to B, but BA is directed from B to A. An alternative notation is to represent AB by A, but we now need to refer to the diagram to find the intended direction. The length of the line segment represents the magnitude or modulo of the vector. This is denoted by AB or A. Note that A is a scalar quantity.
Good morning, everyone. I'm 2052 Nur Yusuf, and today I'm going to explain to you the type of vectors. First of all, there's a plane vector or normal vector, some people may call. This type of vector is just a normal vector. There's nothing special about them. It's a plane vector. Secondly, there is negative vector. A vector of A negative is a vector of opposite direction to A, but the same magnitude as A. Geometrically, negative A vector is equal to BA. Meanwhile, normal vector can be considered as A to B. Thirdly, equal vector or parallel vector only can be achieved when there is two or more vectors are equal in say length, magnitude, and direction. For example, on your screen right now, there is a AB vector where it's initially start from A and terminal and is terminal at B. Meanwhile, there is another vector which is vector CD where its initial at C and terminal at D. Here AB vector and CD vector are equal, although may have different location, which also considered as free vector because they not start from the same origin. And also this type of vector can be translated without changing the vector itself. Next, the first type of vector, also known as unit vector. A vector which has a magnitude of unit length is called unit vector. But suppose if is a vector having a magnitude x, then unit vector is denoted by x in the direction of vector and has the magnitude equal to 1. And finally, equal vector, as I mentioned before, can be only achieved when there is two or more vectors said to be equal in their magnitude, direction, and length are the same. And there is just another diagram for showing how it works. And for now, that is all from me. Thank you for watching.
Vector operations. Now that you have the basic idea of what a vector is, we'll look at operations that can be done with vectors. As you learn these operations, one thing to pay careful attention to is what type of object, vector or scalar, each operation applies to and what type of object each operation produces. Scalar multiplication. The first key operation is scalar multiplication. Multiplying a scalar and a vector. If kk is a scalar and vv is a vector, the product k to vkv is defined as follows. If k bigger than 0 and k to vkv is the vector pointing in the same direction as vv, it's kk times as long as v point v. If k is 0, then k to vkv is 0.0. If k smaller than 0, then k to vkv is the vector pointing in the opposite direction from vv, that's k times as long as v. Vector addition. The second key operation is vector addition. Adding one vector to another, here's how this is defined. If we have two vectors, vv and w in Rn and power of 2, draw vv with its tails anywhere, and then draw ww with head of v point v, then is defined to be the vector that goes from the tail of vv to w. The dot product. Imagine that you have installed a solar panel. As the sun moves through the sky, the angle between the sunlight and the solar panel changes. It's ideal if the sunlight hits the solar panel at a 90-degree angle. The solar panel can capture the most energy this way. On the other hand, if the sunlight happens to be parallel to the panel can get any energy from the sunlight. In this example and many others, the angle between two objects is important. The dot product is an operation on vectors that enables us to easily find the angle between two vectors. Scalar component. Scalar tells us how far and in which direction along each coordinate axis the vector goes. This idea can be generalized to directions other than the coordinate axis.
Assalamualaikum and hello. My name is Ahmad Luqman bin Zubairi. Today, I want to explain how to solve this question. The important thing we should understand the question first. Based on the question that J and M and KLM are straight line and point L is a midpoint for KM. Last point is 3JN equals to JM. Let's read the question first. Give that JK equals to 4A and JM equals to 6B. Express each of the following vectors in the terms of A and B. Let's solve these three questions. So for the first question, K to M. Based on the question, we already know that J to K is 4A and J to M is 6B. Firstly, we should change the JK to KJ so that KJ be a negative 4A. So to solve it, we should use the equation is Km equals to Kj plus Jm so that we can get the answer. And the answer is negative 4A plus 6B. Okay, for the second question is M to L. Based on the first question, we already get the Km is negative 4 plus 6B. So, step for solve this question is Km divided by 2. Why divided by 2? Because based on the question, L is a midpoint for Km. So that we can get the value for KL and LM. After divide by 2, we get negative 2A plus 3B. This answer is for L to M, and we should change to M to L so that we get 2A minus 3B. Okay, and the last question is J to L. For the question, is only use the equation. It is JL equals JK plus KL. JK is 4A and KL is negative 2A plus 3B. So we just add in the equation so that B 4a plus negative 2a plus 3b. From this equation, we can already solve it. And lastly, the answer is 2a plus 3b. So now, I will explain the second question. Based on the question that given, a equals to negative 2i plus 5j plus 7k, and b equals to negative I plus 4j plus 3k. Let's solve the two questions. For the first question, a minus 2b. So, for value a is negative 2i plus 5j plus 7k. And for the value of 2b is negative 2 bracket negative 6i plus 4j plus 3k. After that, we should solve the value of 2b first. Then it becomes negative 2i plus 5j minus 8j negative 6k. After we solve this equation, we will get the answer is 10i minus 3j plus k. But this question not finished yet. We should square root the 10 square plus 3 square plus 1 square equal square root 110. And the final answer is 10.488. For the second question is 3a. 3a becomes 3 bracket negative 2i plus 5j plus 7k equals to negative 6i plus 15j plus 21k. We have to square root the negative 6 square plus 15 square plus 21 square and equals to 26.495. After that, we should divide negative 6i plus 15j plus 21k with 26.495. And the final answer will be negative 0.226i plus 0.566j plus 0.793k. That's all from me. I hope my explanation just now are clear. Thank you.
Conclusion. To plot this experiment study with the editor through the completion of the gradient experimental result, the graphical conclusion for server construction for server cost. Our conclusion for triangle X and triangle Y give result that did not exist. The absolute value for the sum of the x negative and y negative component. This 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 the demonstrated that the force for this experiment when not equ equilibrium, but the value of uncertainty allowed this experiment to have validity. This show this showed that there is a difference between the experimental that graded in that data graded in this experiment and the data gathered from the graphical conclusion contraction because in the experimental we had equilibrium, but in the but in the graphical equilibrium was achieved.